All right, as you can see, we have here a brand new topology. I'll show you the configurations of EIGRP, because remember, EIGRP is for medium-sized to large enterprise networks. The only thing with EIGRP that it's Cisco proprietary, meaning you can only use it on Cisco routers. And that's not a bad thing. It's just that you're limited to those particular routers. Even though EIGRP is a great routing protocol, and why is that? All right, so I'm going to go ahead and click on router 1 all the way over here on the left. Is labeled 0. So we're going to go ahead and open that up. And let's fix our little box right here so we can see the information. Let's move this up a little bit more right here. And let's do a Control-C to start fresh. And we'll do a show start. All right, and basically you put the IP addresses like you would on any router, turn on the interfaces. But here's EIGRP. This is how you would configure it, and we will. But it's basically the same thing. The only difference, or one of the main differences, is this number. What is that number? And we'll speak on it a little bit later, but it's called an autonomous system number. All routers must be in the same autonomous system number so they can talk to each other. In more complex networks, you can go ahead and do multiple autonomous system numbers and then do redistribution. But for our purposes, we'll do it with all in the same autonomous system. All right, the things that EIGRP does, it creates these tables. These are called the topology table, the routing table, obviously, that keeps different types of information in there, and the neighbor table. When we do, let's take a look at the topology table real quick. Just a little very quick look at the topology table, show IP, EIGRP topology. And you're going to see a bunch of information. And don't get overwhelmed. You have something here that says codes, what the P stands for, or if you have an A or a U. In this case, we have a P. P is good. And what the topology table is going to do is have all the routes that exist to all the networks inside there. All right, our routing table, show IP route, that we've seen with RIP. Let me go ahead and bring that up here so you can see a lot better. You see already the letter D. Why the letter D? Well, RIP was R, that makes sense, but EIGRP is D because of the algorithm. The algorithm that calculates all this is called the dual, D-U-A-L. And it comes up with this fancy number you see right here, which is called the metric. And the lower the metric, the better. So EIGRP does a very good job because it takes a lot of things into considerations, such as what? Let's take a look. Show interface S0/0/0. Enter. And let me scroll down. And you can see all these different things here. It has MTU, bandwidth, delay, reliability, and load. So it takes all these criterias and it does this fancy math to come up, hey, which is going to be the best way to get to where you want to go. So these criterias, they gave it a name. They gave them K values. That's what they're called, K values. Can you change them? Yes. And we will be changing this one right here because bandwidth is really a logical variable that we can use with EIGRP to tell it, hey, I want you to go this way, not that way. But even though the routing protocol itself, it is very intuitive, is very intelligent in what it's going to do, but we can also manipulate it. We can tweak it to make it work like we want it to work. But it still has its limitations because EIGRP is still considered distance vector routing protocol. Just because it's an advanced distance vector routing protocol doesn't mean that it doesn't have its limitations. And let me show you. I'm going to go to router, EIGRP 100, which is our autonomous system, and I'll put a question mark. And you can change things in here, such as the distance, okay? You can actually modify the metric. You can do many things in here. One of them that you're not seeing here is the hop count. The hop count by default for EIGRP is 100, meaning it can only go up to 100 routers by default. But you can change that. You can change it up to 255, which I think is pretty good. That's a pretty large network right there. So even though it's still using hop counts, is a large number of hop counts, and is also analyzing the lines, the traffic, the load to send it in a better direction. Unlike RIP, which it goes in a straight line. RIP does not analyze anything. RIP just sends it. If it's a straight line, that's the way it's going to go. You can have a dial-up, and if it's a straight line, it's going to choose dial-up over, let's say, a gigabit. It will choose the dial-up if it only sees one hop, okay? So this is one of the benefits of EIGRP. Things to think about: the autonomous system number. All routers must be in the same autonomous system number, unless you're going to create a network that's so complex that you need to maintain all the inconsistencies within that one autonomous system. Then you create multiple autonomous systems, and then you can redistribute them into each other. But that's pretty much EIGRP in a nutshell, okay? We have autonomous system numbers. We have metrics, which we saw in the routing table, right? This huge number right here that the dual algorithm is going to calculate and find that the lower administrative distance is the one that's going to make it to the routing table, because that is the best path to get to where you want to go. So EIGRP, yes, only Cisco, but hey, using Cisco routers is not a bad thing.